the presentation by Valery Zaichko, who is the division head with ROSCOSMOS. He will tell us about innovation projects of Russian remote sensing system development. Valery, happy to welcome you also as the platinum sponsor, not just a regular speaker. So we're all ears. Good afternoon, or rather good morning, distinguished colleagues. Let me introduce myself once again. I am Valery Zaichko from ROSCOSMOS, Deputy General Director. Don't be embarrassed by the name of my department. There's been a reorganization. My job is to oversee remote sensing capabilities, and that includes ground station network. Since Victor berated me, scolded me a little that I may have taken too much of my time, my presentation this morning is going to be very brief. Should there be any questions, I'll be more than happy to take them. So I will briefly elaborate on the key areas of development in Russian remote sensing system. First of all, that includes creating, maintaining and upgrading our constellation of satellites. Second, development of ground infrastructure, reception, processing, analysis and distribution of data. Thirdly, creating and improving processing of big data, improving storage capabilities and delivery modes. Promoting international collaboration in remote sensing is one of the key areas too, which is what we're doing right now, right? Currently in orbit there are 8 satellites. The constellation includes several subsystems. First subsystem is the nature and environment subsystem, including 2 orbital constellations. First is resource P. You can see its technical specifications. During the second session, my colleagues are going to share with you some information about resource B and other satellites orbiting the Earth. The system includes 3 units. The system allows obtaining panchromatic 0.7 meter images and 2.3 meters in multi-spectrum mode. So this 3-unit constellation allows us to promptly address tasks facing ROSCOSMOS, deliver on orders that we get, and try to address some commercial requests as well. I am not going to show you images, it's not that fun. Canopus V is a satellite orbiting the Earth, which is beyond its active service life. My colleagues from VNIEM are going to tell you what this unit does and how you can process data from it. Canopus constellation has 2.5 satellites in it. 2.5 That's because Canopus 1 is in operation. Canopus VIK, or infrared, is going through flight tests, and the flight tests should be completed by November. The test is A-OK. There is infrared capability on board that unit that can identify fires with area of 5 to 5 meters. So far so good. If flight tests turn out well, we are going to mount this equipment, this payload, on other satellites as well. A couple of days ago we've sent Canopus 3 and 4 to Vostochny space launching site. So why do I say 2.5 units? That's because we also have a Belarusian satellite, which is part of our constellation. So it's a joint Russian-Belarus constellation, and a Belarusian satellite is a twin satellite with Canopus P. So toward the end of the year we should have a complete constellation in place with 4 units. We intend to launch 2 more units, number 5 and number 6. That's the trend. The nature and environment remote sensing units includes 2 subsystems, resource P of super high resolution, better than 1 meter, with 3 units, and Canopus with 4 units. They're going to operate by the same design, the same concept, so that we could have revisit capabilities up to 1 or 2 a day. So this will help us not only observe and monitor the Earth, but also do some jobs involving emergencies and disasters, which is very relevant for Israel. If you remember, last year we had fires, and we provided a lot of data from Russian satellites for the benefit of Russian disaster management authorities. We have 2 more constellations of hydrometeorological nature, but I guess it's not that interesting for you, the photogrammetric community. In a nutshell, this is a meteor system with 2 units. For the WMO benefit, we provide online data. And electro satellites, these are geostationary hydrometeorological complex sitting on the geostationary orbit. We have 1 unit at 76 degrees over the Urals. Next year we'll launch another one. Again, there will be 3 units in the constellation fleet to have a revisit of 30 minutes. A drawback of our satellite constellation is some missing parts, and that is radar capabilities. However, thanks to the Research and Production Center of Progress, 2 units are going to be finished very soon. One is Obzor R. My colleagues are going to introduce to you that system. There will be 2 satellites as part of the orbital constellation. In 2023 we plan to launch the first satellite. But to bridge that gap, we're about to release Candor FKA, in the early 2019. We're planning to launch the first one in the 2020, the second one. They will fly in tandem, delivering interferometric capabilities. I think it's also important and relevant for the people here. To replace resource P, which includes 2 units in operation and 1 more in the production, by 2022 there will be 3 or 4 units considering their active service life. Resource PM will be a replacement. It's the preliminary design are being done on it. Roscosmos set such parameters so that it will address mapping purposes primarily. At the moment, resource P is used to create topographic maps. We provide a ROS-register with imagery from this satellite to cover a number of topographic maps. Resource PM will be tailored to mapping purposes with GDS point 0.3. So we believe that this will be a worthy replacement to resource P. Also, our plans call for a system of at least 3 units, and all in all we should launch 6 units by the end of the accounting period in 20, the first one 21st, the second one, and so on. So to replace a resource P, we will have resource PM coming onto the orbit. As for the specialized mapping system, we had such plans to get it in place. We wanted to have 2 subsystems, one for radar. Unfortunately, our dreams were not to come true, and at the moment Roscosmos plans do not include such developments. As for our prospects, we are pursuing the Federal Space Program of Russia. It's a programmatic document covering a period of 10 years until 2025. Funding is committed, and this slide gives you an idea of what we plan to produce and launch, so that by 2021 we could reach global Earth coverage and create mosaic coverage and updating them, not only for Russia but for the rest of the world as well. So the ultimate goal is to have up to 20-25 satellites of all kinds: meteorological, natural observation, and to maintain the constellation on a permanent basis like that. And for the next programmatic period we'll have different plans, of course. The second line of activity is developing and supporting the ground infrastructure, receiving, processing, distributing remote sensing data. You see the current infrastructure as it is now in place. It's called the Common Territorially Distributed Information System. In terms of receiving centers, it's more or less done. In the south of Russia, the system operates very well. We're now targeting the Arctic area. The first reception center was established in Murmansk. It operates effectively, collecting data not only for Russian satellites but from foreign ones as well. And we're getting 2 more reception centers online. The first in Dudinka, that's in permafrost area, and in Anadyr. So this will complete the cycle, and we have an ambitious goal to create a reception center in the Antarctics, like India and China have. We are loading a vessel with payload to head for the Antarctic. I hope that next year we'll have installation works, and in 2019 we will get it in place. So this will complete our effort to establish a network of ground receiving stations. So we will complete the infrastructure with this. To transmit data from the Arctic and Antarctic, we have the Luch system on the right. These are 3 retranslation units covering practically all the Earth, so that all the information received by a receiving station could be relayed to other receiving stations in Russia. We have 2 stations for that, one fixed and the other one mobile. It includes 2 containers that move around. We showed this mobile complex to Russian FEMA. It can be loaded on a vessel and delivered to any point on Earth. Ministry of Emergencies had 3 such systems ordered from us. The next element of ground infrastructure is not only receiving stations but data exchange centers as well. We agreed to rent a communication channel with our communication authorities. An important element of the ground system is the single bank of spatial data, which incorporates regional banks. At each center there is a regional bank, but they are all part of the same cloud space, and all data that we have today is available as a cloud service to all users. Roscosmos has a geoportal that has 2 components. First, geoportal itself, that you can access to get high resolution and other data, and there is an open source data. You can log into it and download images with resolution 30 meters or worse. So anyone can get there, but if you need to have high resolution imagery, you need to register, get your account opened, and order acquisition and have it delivered either from the archives or freshly baked. This is the ground infrastructure. As far as data processing is concerned, I already told you that the President adopted respective decisions to prioritize remote sensing and primarily to create services and products that will be available and accessible for any user and would help address various tasks in the interest of all socio-economic relevant objectives. These are applications that you are all aware of, but since we're here to talk about mapping application primarily, we have close cooperation with RosRegister, the primary producer of maps.
Also, we spoke about how we cooperate, and because of the efficient use and operation of the interdepartmental group for the use of data for the interests of the mapping, we managed to increase the share of Earth remote sensing data when drawing maps from 40% to 70 to 80%. Now, the RosRegister requests that we annually receive and which are operationally updated are covered by 80% using only the Russian source data. 20% of data comes from foreign sources because of the lack in our orbital constellation some of the satellites that cover Arctic zone. In a year or two we still have areas that we cannot acquire in up to 5-year gap. That's what we have small deficiency. And the last thing I wanted to tell you about in today's presentation, we fruitfully cooperate with the international community on the exchange of remote sensing data and operation of our satellite constellation. We have a joint Belarusian-Russian constellation. We use the resource of the Belarusian satellite. We have signed an MOU on establishing a joint constellation of BRICS countries, South Africa, Brazil, China, Russia and India. Will use the data acquired by satellites of those 4 other countries. Tomorrow, on the margins, on the sidelines of the Kazakh remote sensing conference, there will be an Eurasian Economic Union countries workshop where we'll be discussing the establishment of the constellation of among the countries of Belarus, Russia, Kazakhstan, Kyrgyzstan and Armenia. And the main source of data for us is the Charter, Space and Large Disasters. Russia has been a member of this charter for a while now, and it includes 16 associated members. And this Charter's constellation has 45 spacecraft at the moment. The materials acquired from this international joint constellation are shared with all the members of the Charter whenever disasters happen, free of charge, and whenever we have a disaster, not only in the territory of the member countries but on other territories, we also share this information and acquire it whenever needed. So for Russia, it is a very good additional source to get various valuable pieces of information, considering the vastness of the territory of Russia. Our plans include the establishment of the National Remote Sensing Center, which will implement all these projects, including the Digital Earth project. Dear colleagues, briefly, this is what I wanted to tell you. That is why I thank you very much. The Digital Earth project, you saw it yesterday. If you want to, I can show this video to you again. Thank you very much. Dear colleagues, will there be questions for the speaker? Yes, Victor? Valery, you want to put on your headphones because I don't understand Russian. You spoke about the 2020 horizon and you look at such bulky satellites like Resource P, Resource PM. They're quite heavy duty and large satellites. Do you have any plans about small satellites, constellations for super small satellites or nano satellites? I will answer first of all by saying that Canopus satellites are considered to be small satellites, under 400 kilos. So we think it is a small satellite with an open platform. That's why we focus mostly on the development of this constellation. It will continue to grow. As far as nano satellites are concerned, ComSats and others, we, under the federal space program, do not expect to build such satellites, and we give it away to commercial companies, private companies, and we had a company, Dauria, who developed such companies, and the company Sputnik was also developing such nano satellites. So we give it away to startups from Skolkovo and others. So far we don't have plans to focus on nano satellites. Other questions? Do people use catalogs and information? Please raise your hands, those who do. Rakurs uses them. Okay. Do you, as a user, have any recommendations or feedback? Questions about the quality, quantity? Sergey has something to say. We once raised a question that some users, when getting information from foreign satellite suppliers, have restrictions in their rights of use. My question, whether Roscosmos can assume a function of building a single window opportunity in Russia so that the data coming to Russia could be multiple use data. Is Roscosmos thinking of becoming a monopolist in this regard? Thank you for your question. Yet another direction of our work. It is lawmaking activities in the remote sensing. And unfortunately, at the moment, this is where we are sorely lacking, but we're trying to improve. You know, there are only 2 or 3 governmental resolutions that regulate this activity. It's first resolution number 370 from 2015, which was the seminal point in our lawmaking activities that was regulating the activities of large resolution apparatus. Then 1390 resolution, which, owing to the efforts from the group, owing to the efforts of commercial structures present here, like Vladimir Evgenievich's structure, we have stripped all the secrecy for the Earth remote sensing data, and any Earth remote sensing data acquired from the civilian satellites, independent of their resolution, are not considered as state secret. That's number one. Independent of the spatial resolution. Yesterday, there was a meeting at the level of Deputy Prime Minister on settlement of conflicts on the issues of amending the law on aerospace activities in terms of a maintenance of the federal database on Earth remote sensing data. Yesterday, all the conflicts have been settled, and next week this law will go to the State Duma for the second reading, and before the end of October we expect it to be adopted on the second or third reading by the State Duma. The main idea of that law, which was started 5 years ago, we started to develop that bill 5 years ago, and as long as I was one of the forefathers of this bill, the idea was to establish a single Earth remote sensing data sourced from Russian and foreign satellites. And in the first version of that law, we had an idea, just like you ask your questions, to have a single window approach, which would go to the federal fund and see what it has. If some information is lacking, which is needed for their activities, then they would plan additional space acquisition or if it is not possible, then they submit the request to procure this data from foreign operators. Unfortunately, the Ministry of Economy and the Ministry of Finance didn't endorse this option of the law, and now the only thing we managed to do in our law, in its current version, we have a provision that if a federal fund of data lacks the data required for, I'm talking about state agencies now, then they have the right to buy this lacking data from foreign operator. But number one, they are obliged to buy multi-license, not a regular one, single user license, but multi-license. And secondly, a copy of this data will be deposited with the federal fund. And this is an answer to your question. And in conclusion, in my story about the lawmaking, again owing to our joint group efforts, I think it was called Earth from Space. Well, in fact, I will also ask a question about lawmaking practices. They're continuing. There is a national initiative which intensifies, also in our sector, the lawmaking activities. And from my side, I would like to ask a question. Now, we have undersigned a big federal program called Digital Economy, and it contains points 4.14 and 4.15. Those people who want to look it up, they're writing up a list of activities already. And my question for Valery is following. As long as the National Technological Initiative for Development Strategy is not looking at particular sectors, but rather at how economy is structured, and digital, big data, usually there is plenty of data but no information when big projects are implemented. In fact, expecting the subsequent development of navigation of digital means and mixture of standard conventional survey approach implies serious modification of technologies and the spatial and temporal resolution in that regard. The bullet points related to Roscosmos and geodesy, you mentioned that you now work with registry and mapping applications. Now, these 2 points have been subdivided, 4.14 and 4.15. 4.14 is about the space part, 4.15 and 4.14 is about survey and mapping applications. We understand that includes and applies not only Earth remote sensing data, but also precise positioning and building of polygons. These are infrastructural cross-cutting issues. Do you think it is correct to subdivide these 2 points in the program, which for the next few years will predetermine the geo-digital space and the development of new technologies? You see, those bullet points are subdivided to 2 parts: spatial data and Earth remote sensing data sourced from space. Why did we decide to do it this way? At least for the next 2-3 years until 2020, if you remember, there are some milestones. Milestone is the establishment of a system, establishment of a digital platform for collection processing. That's 4.14 of spatial data, and the second one, similarly, establishment of a digital platform for collection of Earth remote sensing data. Why did we decide to do it like this? And the government supported us with that, and the program was approved by the Prime Minister. In fact, we did it because of the legislative norms in our country, issues of regulation of relations in land survey and mapping applications and spatial data, and their description, notions, definition, structure, system building, establishment of a single mapping platform. Everything is described by that law, and the activities related to Earth remote sensing data and aerospace activities are regulated within the law of the aerospace activities. And now if we adopt the law on the Earth Remote Sensing Data Fund, it already will be legislatively subdivided. The notion of Earth Remote Sensing data in the law number 431 is lacking, and I agree with you that in principle it should be a single platform. But at this stage, for the next 2 or 3 years, so far we are going to do it separately. But by the year 2020-2022, we're going to merge them. We have a pre-agreement with Rostelecom, who is the main supervisor of that section of digital infrastructure. And within the framework of our working group, we have already pre-agreed that the working group will be a single one, and it will be called Geodata, within which these two milestones, these two activities will be considered as one. Thank you very much, dear colleagues. Okay, the last row, Mr. Bolsunovsky from Sovzont, about the data fund. I understand that this law has been pre-endorsed already in its most recent interpretation. I have the following question. Today, after lunch, we'll have presentations on some changing paradigm on what is Earth remote sensing data and what to do with them under the new conditions, because new things are appearing related to services and other things. A quick question. In different projects, people could use planet data, planet constellation, which works as follows. They open access to an area of interest like the Moscow district, and there are plenty of coverage and overlaps, petabytes of data. Based on the logic which is described in the new law, it looks like first you need to get a license for these data, which are supplied as services. You can switch off all this data. You can download only one layer, or update it with a second layer for the future. So the question is, this spatial data fund, I understand we need to upload this data into there. It will contain only metadata. So if the physical data are bought by license and are updated there by the new ideology, when 250 satellites acquire these images, and I don't think that there is a single data fund that can survive this kind of barrage of data. You see, this data fund was designed for a conventional mode of use. That is why what you're saying here indeed is exactly what it is. But considering new realities and considering new trends in the development of remote sensing equipment and the services provided by planets, we are aware of that, of course, and in fact first of all, our data fund will be in cloud. We'll also provide service. We're not going to download or upload data. Any user can enter the cloud and works with the data and process this data also thematically and gets only a service. And we have plenty of resources to process this data, any kind of data, and this is the vision of what we'll have in our data fund. That is why we are thinking about uploading service and planet both also into this fund. We are now in negotiation with them. Perfect. Thank you very much. Let us give a round of applause to Valery.